Okay, in this method we're going to be looking at the proportion method on handout 33. So this technique involves some visual rescaling and proportionality. So what we do on this one is we're going to draw a rectangle, and you will see that on one side of the rectangle, this was on the top, we're going to put our percentage. So imagine filling this rectangle up. Okay, so you're going to start at 0%. If you fill it all the way up, it'll be 100%. And then on the bottom, we will see our numbers going from 0, in this case, to 400. So we're going to go from 0 to our base. Now this problem looks familiar because we did it on the last page. We're asked to find blank is 20% of 400. So what I'm going to do is I'm going to kind of visualize between a 0% and 100% where I think 20% is. So maybe about right here. All right, so I'm going to write 20% on the top because I'm doing all my percentages on the top. And I don't know what 20% of 400 is going to be, so I'm going to put an X here. So you kind of imagine this rectangle being filled up 20%. Now what this does is it allows you to set up a proportion. It's a little bit like a ratio box in that it sets everything up in a nice order. All right, so just ignore this right here. We're going to come back and talk about different ways to set up a proportion. But let me just show you with a highlighter kind of what I'm seeing. So I am seeing 20 over X, 100 over 400. Okay, I'm going to delete those. So I'm seeing 20 over X equals 100 over 400. So that gives you a proportion that you can solve. Now notice it's not the same as the one I just scratched out. We'll talk about that in a minute. So when you are working with a proportion, if you don't have a calculator, if you want to clean it up, you can simplify either side. So I could simplify this side. What you can't do is you can't simplify across an equal sign. So that cannot be reduced. So don't reduce. So you can't go across the equal sign, but you can do a single fraction. All right, so let me clean up my mess here. Oops. All right, so I'm going to reduce 100 over 400 to 1 over 4. Then I'm going to cross multiply. And I get 1 times x equals 20 times 4. So I get x equals 80. All right, so that's one way to set up the proportion. I'm going to show you in most textbooks that you'll see in middle school proportion, you will see this, and this is what generally students are being asked to do. Part over whole equals percent over 100. All right, so we talked about the part in the last video. Whole is the same as the base. All right, so let's see if we can use this particular picture to make our proportion look like a textbook proportion. So basically what we're doing is we're turning it sideways. In a regular class, I would turn my paper sideways, but I can't do that on the video. So I'm going to redraw this rectangle over here. Let me do this in a different color. So I'm turning the rectangle. So if you want, you can just turn your paper so that I'm seeing this on the top and this on the bottom. Now remember, we've got this part filled in, we've got 20%, and we've got X. All right, so now if I go to get a proportion out of this, I'm seeing X over 400 equals 20 over 100. So I would see X over 400 equals 20 over 100. So by turning it sideways, I'm using this equation now. I'm doing part, which I don't know, to my base of 400, and then 20% over 100. So this is also a valid proportion. Remember, I can't reduce across an equal sign, but I could make that fraction on the right. I could make that 1 over 5. And then when I cross multiply, I would get 5x equals 400, divide by 5, and I would get x equal 80. So these are both valid proportions. They are the same thing. You'll note that the cross products end up being the same. So you can kind of pick how you want to turn your rectangle. All right, so let's try another one. For number 2, I have blank is 75% of 52. All right, so I'm going to draw my rectangle. Okay, so I want percentages on the top, 0% to 100%. And on the bottom, I want to go from 0 to the base, and I can see that my base is 52. Now I'm asked to find 75%, so I would estimate 75% to be about right there. And I don't know what x is. And if you want, you can kind of fill this in. All right, so I have 2 options. I'm going to show you 2 ways to set up the proportion. One is to just look at what I have here, 75 over x, 100 over 52. So I'm saying, oops, just kidding. 75 over x equals 100 over 52. Now, if you rotate your paper, which I'm not going to redraw the rectangle again, if you rotate your paper, you will see it this way. X over 52 equals 75 over 100. So this one is that part to whole percent over 100. Now, which one I use, to me, would depend on which one would simplify more easily. And it looks like this fraction would simplify really nicely. So I'm going to use this one. I get x over 52. And then this simplifies to 3 over 4. So that might make my life a little bit easier. All right, so when I do my cross multiplication, let's see what we get. We get 4x equals 52 times 3, which is 156. Okay, and then we're going to divide by 4. Let's see, 4 into 156, that would go 3 times, 9 times. So I get x equals 39. All right, so that one made the arithmetic a little easier without a calculator. All right, so let's try number 3. I'm going to start by drawing my rectangle. I'm going to go 0% to 100%. And then 0 to my base, and it looks like my base is going to be 83. All right, so notice on this one, I'm not given the percent, but I'm given the part. So that's a number, not a percent. It's going to go on the bottom. So I want to eyeball where I think 50 falls, maybe about right here. And then I don't know my percent, so I'm going to put X percent. All right, I like to kind of scale this. I know that 50 is a little more than halfway between 0 and 83, so I'm expecting my answer to be a little bit more than 50%. Now, I don't really see a nice way to set this up, so I'm just going to go with how it's sitting in front of me, x over 50, 100 over 83. So x over 50 equals 100 over 83. It doesn't look like anything reduces, so I'm going to go ahead and cross multiply. 83x, so 50 times 100 will be a 5 with 3 zeros. Now this one's not going to come out pretty, so I have to figure out how I want to put my answer. All right, so let's think about if I do the long division of 83 into 5,000. I don't know if I have room for that. Let me squeeze this over here. All right, so we can't go into 50, but we can go into 506 times. That would be 498. So you got to be careful with this one because 80 doesn't go into 20, so that's 0. And then I just have a remainder of 20. So that's going to be 60 and a remainder of 20 over 83. Now remember, my answer is supposed to be a percent. It's already in percent form, okay, because I used 100 as a percent. So what's nice about these is they do come out in percent form. All right, so that's going to be cleaner than using a decimal. Not very pretty, but there it is. All right, let's look at number 4. This one we don't know the base. We're missing the word after of. So if I go ahead and set up my rectangle, I know I'm going to go 0% to 100%. And I'm going to go 0 to my base, but I don't know my base, so I'm going to put an X there. Now I want to put in 150%. Now that's bigger than 100%. So what I'm going to do is I'm going to kind of dot this out a little bit. It should be up here somewhere. So 150%. And I know once I take the 150%, I'm going to get an 8. Now I have a couple of ways to do the proportion. I can think 100 over x equals 150 over 8, and that's fine. You can do it that way. If I turn this sideways, I'm thinking x over 8 and 100 over 150. So I kind of like that one. X over 8 equals 100 over 150. And the reason I like that is that fraction reduces quite nicely. Let's see, 50 goes into that 2 times and into that 3 times. So this is something I might give you on a test because it does reduce quite nicely. If I cross multiply, I get 3x equals 16. So that part's not quite as pretty. So 3 goes into 16 5 times with 1 left over. So I get a base of 5 1/3. All right, so I do like the proportion method because it does go along with most textbook methods for solving these